We have recognized that we will need two functions for our purposes. And so I'm going to have a function line A, B, C. So you don't have to do this, but Python does allow something called type hints now, which lets you know what you would expect these input variable arguments to be. And I usually use them now. You don't have to, you can just have this be a function of B and C and not type hint. And I want this to return something I can call. I think there's a callable type that would be appropriate here. All right, so I'm going to create a function that is called, you ready for it, e of xy, and that function returns a times x plus b times y plus c. I'm going to return, you're allowed to have a function that eats things and spits out functions. You're allowed to have a function that returns functions. You can have a function that takes functions and returns functions. In fact, I bet you know one. I bet you have seen something that takes a function as input and returns a function as output. What have you seen before in your life that takes a function as input and returns a function as output? The derivative. The derivative is a box that takes a function and you put it in the derivative box and it spits out another function, right? So you can have a function as input and a function as output. You can have a function that takes, but this should work. What we're doing here is we are defining a function and then we are giving that function back. So this is actually the block of doing the creation of the function and then returning the function. If I did this right, all right, so I'm going to say phi12 equals line of 1, 2. Oh, you know what? Definitely should, shouldn't it? So phi12, let's say phi123 is equal to line of 1, 2, 3. Now is a good time to figure out what is the type of this thing. All right, I'm done with this. So now phi of 1, 2, 3 is a function. So what should I be able to plug into phi of 1, 2, 3? A pair of numbers. Give me a pair of numbers, 3 and 4. Okay. So phi 1, 2, 3 is a function, and phi 1, 2, 3 will give me values for anything. I took in numbers, and I now have a function. I have a function that spit out a function. That's the first thing we have to do. And now I want to define this cost function that we talked about. Tells me how bad my evaluation of this function was at a point. So remember how we defined the cost of an XY pair if we have a prediction function. The cost of a single point is going to be minus the true label of that point times log minus 1 minus the true label of the point times log times 1 minus the predicted value at that. Now, if I say predicted value of a point, that assumes here that I actually have a function that could make a prediction. The x, the y, the true label, and the prediction function in this case. These are the coordinates of my point that I'm predicting with. I'm going to need to know this true label. I'm going to need to know this prediction function. So let's go write that function. So I'm going to do def cost single point, which takes 4 things. Floating point number x, a floating point number y. So x is going to be a floating point number, which is the x coordinate of the point. Y will be the y coordinate of the point. True label will be the actual class of the point, whether it be 0 or 1. And pred function will be a function which takes 2 arguments and returns a number between 0 and 1. And then returns the cost associated with the prediction function at this, which measures how well prediction function did in predicting. I'm going to say prediction is the prediction that is called on whatever my x and y inputs were. And then I'm going to say that cost is equal to minus true label. Oh, I probably need to import log from math or NP. Sorry. So log isn't going to be there natively. So at the beginning of whatever your notebook or code file is, you want to have from math import log. So we're going to have minus true label times log of prediction minus 1 minus true label times log of 1 minus prediction, and then we will return costs. All I'm doing in this code is trying to do what I did so I believe this function will tell us the cost of a given prediction function at a given point. Look at it and see if you grasp the logic of it. So now let's save that. Let's open an interpreter. Do from ML funds import line, and what was it called? phi 1, 2, 3 is equal to line 1, 2, 3. So now phi 1, 2, 3 is the function 1 times x plus b times plus 2 times y plus 3. Do you agree? We can know what phi 1, 2, 3 of 4, 5 should be, and we can double check. So phi 1, 2, 3 is a function that's going to take numbers, and you also have to remember it's possible we're writing code that no one but us will use. So the standard threshold for testing is a bit different versus code that anyone can use. So we have this phi function, and now what I want to see if I can call the cost single point function. So I call cost single point. So cost single point 0 phi 1, 2, 3 math domain error. What's the problem here? Yeah, you're plugging in 0 into log. You can't do that, can you? True label times log of prediction. What am I plugging in? 20
Negative 25. 1 minus 25.
Oh, okay. Well, yeah, but obviously prediction function isn't the line that we built. The prediction function would be the logistic function built on the line that we built. We gotta do that now. Now so what I'd like now is something that takes a function and returns so I want something that takes a line and returns the logistic function 1 divided by 1 plus x negative a times x plus b times y plus c. X is just e raised to the something and a good notation. Now, I could have done this in one go. I could have done this just based on a, b, and c. I'm going to have to import x from math also. 1 divided by 1 plus x negative a times x plus b times y plus c. Return logistic. So let's highlight what you pointed out. From the first issue here is that I don't have an a and a b and a c. I want to use the line function that's being passed. And that's a good point. I have chosen to hide my line function. So I don't have access to the a, b, and c. I just have access to the function I'm being handed. So that is a really good point. Instead of calling a, b, c, I would want to call this x of negative. I'm going to put -1, even though it's probably not necessary here, because I get nervous about. But what else that's a really good point. Thank you for raising that. But there's another issue as well. I'm not getting x and y. So I need to create a function. I haven't created a function to return. So I'm going to do def logistic fun xy return that expression. So now I've created a function that takes in x and y and returns something. And the whole point of my function is to take that function and spit out another function. So the goal of generate logistic function is to return a logistic function. Now I can use generate logistic function. All right, so the last thing we would need to do is we would need a way to write a function that takes all of the points that we would want. So we could do def cost data, and def cost data should only take the prediction function and the data. And the goal of this would be I'm just going to put a comment as a placeholder here, return the total cost of the prediction function over all data to evaluate the cost at a single point and add all of these costs, which is probably the simplest one we've done, but I'm not going to do it.